Today we're taking a look at lesson 16, applying the properties of operations to multiply and divide rational numbers. Your target goals are that you'll be able to use these properties of operations to multiply and divide rational numbers without the use of a calculator. You'll also be able to use the commutative and associative property of multiplication to generate equivalent expressions, as well as the distributive property of multiplication over addition to create equivalent expressions, representing the sum of two quantities with a common factor as a product, and vice versa. You'll also be able to recognize that any problem involving multiplication and division can be written as a problem involving only multiplication. Students can then determine the sign of any expression that contains products and quotients by checking whether the number of negative terms is odd or even. We're taking a look at page 195 in your book. Again, page 195. And I just want to point out a couple of the properties that we're going to take a look at. Probably the two most important ones right now are associative and commutative. Associative is just, you haven't moved any of the numbers, any of the numbers around. However, you started or you put grouping symbols so that you did something first, okay? Whereas commutative property means you're actually moving the location of something. So A plus B is the same thing as B plus A. We've actually moved them, physically switched them. Associative, all we did was move the parentheses, not the actual numbers, okay? So you'll be able to go back and look. On example 1, it says that we're supposed to go ahead and solve this, evaluate it, and then we need to answer the question, will different strategies result in different answers? Why or why not? So I've written it down twice. We're going to go ahead and solve it two different ways. What do you think? Do you think that we will get a different answer? Will it make a difference if you multiply something before something else? The first one, ready? I'm just going to go right here in order using the associative property. So I'm just going to go and multiply the first two. So negative 6 times 2 is negative 12. And then I'm just going to write down the rest of it. And now I'm going to put that negative 12 times negative 2 and get a positive 24. And then I'm going to have my 24 times a negative 5, which is negative 120, times negative 3, which is positive 360. Now let's go over to the other side, and instead of using the associative, at some point we're going to change. We're going to use something different, okay? So right away, I'm going to go ahead and instead do this part right in here. So as I do this, I still have my negative 6 times 2, but now I have negative 2 times a negative 5, which is a positive 10. And then I still have my negative 3. Then at this point is where I've decided I'm going to switch something. I'm going to go ahead and I'm going to put negative 6 times 2. But then I'm going to move my negative 3 right here, and I'm going to put my 10 at the end. And the reason I'm going to put my 10 at the end, so this right here is commutative property instead. Okay, these were all associative. And the reason I'm going to put my 10 at the end is it's easy to multiply any number by 10. So if I save that till last, all I'll have to do is add on a 0. So after I do this, I'm going to go ahead and do that 2 times a negative 3, and I'm going to get a negative 6. I still have my -6 out front, and I have my 10 at the end. -6 times -6 then is 36, and a 36 times 10 is 360. So did my answer change? No, it did not. It does not change anything. Now, what types of strategies were used to evaluate those expressions? Well, what did we do? We rearranged. Which was the commutative property. We used order of operations, maybe. We might have used grouping symbols. Which is our associative property. Now, it says, can you identify the benefits of choosing one strategy over another? Why would we do one of the ways instead of a different? Well, sometimes it makes it easier to solve certain areas first. Or in this case, we saved the 10 to last because multiplying by 10 was going to be a whole lot easier at the very end. What is the sign of the product and how was the sign determined? Well, what was our answer? The sign of the product was positive, right? But how? How do we know what it was? Good. Well, when we know an even number of negatives equal a positive, and an odd number of negatives equal a negative. So if they have a partner that they can match up with, it'll always be an even answer. But if it doesn't, then it's going to be an odd. Okay, on this next one, that's not what I wanted. There we go. On this next one, we're going to go to exercise 2, and it says find an efficient strategy to evaluate this expression and complete the work. Okay, so I'm looking at those fractions, and I don't really like those fractions. So what I think I'm going to do is I'm going to right away rewrite it. So I'm going to write 4, and I'm going to move this -1/2 over here times the 4. And then I'm going to write the rest, -8 times 9. But now I'm going to move this -1/3, or +1/3, sorry, over by the 9. And the reason I'm going to do that, commutative property, is because I see that 2 is a multiple of 4 and 3 is a multiple of 9, or factors, not multiples, factors of, and therefore I'll be able to cross cancel things. So when I do this, I have half of 4. Well, what is half of 4? It's 2. But I have one negative sign, so I'm going to keep it. So I have -8. And then again, I can cross cancel here, and I'm just going to have a 3. Now I can do -2 and -8, which is +16 times 3, and 16 times 3 is 48. Now, what terms did you combine first and why? Well, that's what I was telling you is I multiplied the -1/2 times 8 and the third times 9 because their products are integers, and that way we would get rid of those fractions. Now, if we look back at the examples and exercises, do you see any way to determine the sign of a product first? Well, how can we tell just by looking at something if the answer is going to be positive or negative? We are actually going to count the signs, right? Count the negatives. So odd number is negative. Again, and an even number is positive. Example 2, using the distributive property to multiply rational numbers. Well, we're going to rewrite the mixed number as a sum, then multiply using the distributive property. So let's see what we're going to do a little bit different here, okay? So if we start off with this, and now we're going to be able to separate this. So I'm going to have a -6, and I'm going to have it times. But right here, I'm going to say 5 plus 1/3. I'm breaking that up. Now, as I do that, I can actually say, well, now it's a distributive. So I'm going to distribute that 6. So I'm going to have -6 times 5 plus -6 times 1/3. Make sure that you have that negative sign with both. -6 times 5 is -30. And I can cross cancel here, leaving me a -2. And then we can put those two things together, and we can say -30 and a -2 is a -32. So we just broke them up.